Okay, here's our last one. We're going to do some more tangent and secant just so we get the hang of it. Tangent cubed x, secant to the fourth x dx. Now something I want to point out to you here. There is more than one way to solve this problem. What? Is that real? Yes. We can look at this and think about our toolbox. We know our identity. Tangent squared x plus 1 is equal to secant squared x. We know that the derivative of tangent is equal to secant squared. We know the derivative of secant is secant tangent. No matter which way you pull this off, right? No matter how you pull this off, you are going to be looking at secant and tangent are buddies. So the first way we're going to do this, and it doesn't always happen this way. Sometimes there's only one way to do it. This particular problem, we've got a couple angles we can go for, so let's try them out. Here's option 1. I'm going to make my u tangent x. So if that's happening, I'm going to have tangent cubed x, and I've got this secant squared x, and I'm going to pull out this secant squared x because that's going to be my du, right? If my u is tangent, my du, I have to reserve something to sub in as my du. So tangent cubed x, and then I'm going to use my identities because I want everything else to be in terms of my u. So my u here is tangent. My du is secant squared. And I have u cubed, u squared plus 1, du. And it just got real easy. You see that? Then you distribute. Like bases, you add the exponents. That's u to the 5th plus u cubed. So I've got a 1/6 u to the 6th plus 1/4 u to the 4th plus c. And my u is a tangent. 1/4 tangent to the 4th x plus c. There's option number 1. Let's take a gander. What if I wanted my secant to be my u? Because check me out. I've got an odd exponent of tangent, so I've got an odd man out tangent, right? I can make that odd man out tangent for a secant tangent. I'll pull one of my secants and one of my tangents for my du. Well, let's do it right here. We've got room. Option 2, where my u is secant. Again, you can't always do this, but sometimes with these problems, it works well both ways. And I want you to just see more options. So you just have to think it through. And as long as your work supports your answer and it's correct, I'll take it. All right? So in order for secant to work, I have to pull out a tangent and a secant here. So I've got tangent squared x, secant cubed x now because I need a secant x and a tangent x to be pulled out here for my du. Which means if my u is going to be secant, then everything has to be in terms of secant. So I'm going to rewrite that tangent. So this is secant squared minus 1. And secant cubed x, and then I've got my secant tangent. So if u is secant, du is secant tangent, and there it is. U squared minus 1, u cubed, du. We're back to a polynomial. One-sixth u to the 6th minus 1/4 u to the 4th plus c. And now this is secant. I've got a little bit of room down here. 1/6 secant to the 6th x minus 1/4 secant to the 4th x plus c. It is okay to have more than one answer because when you go to plug this in, your values will end up being the same. If you want to say add a certain value, if I make this a definite integral, my definite integral will still have those same values. Again, it doesn't always work that way, but with tangent and secant, go back to the toolbox. With sine and cosine, look for those odds and evens. If it works this way for tangent and secant, it also works this way for cotangent and cosecant. All right? I don't need to work a bunch of examples of those. Follow the same pattern and you've got it. Okay. Go rock the socks off some trig, you guys.